And with calculus, you have a lot of word problems because that's what really we use this stuff for. Like when you're putting rockets and things into space, or you're talking about particles at a subatomic level and figuring out where they show up and how fast they're moving. You know, those particle accelerators that run things around there at the almost speed of light, right? So this is what we really want to get good at after practicing how to do it on just regular, generic problems. Let's actually use it for a real life thing. And we often start in calculus with an object just going up into the air and falling back down to the ground, right? So as you can see, we got a parabolic curve here, right? And often we'll have these. This is why, and it's opening down. It's a parabola opening down. This is why it's a negative. You'll see often it's a negative 16t squared, or if you're in, sometimes it's negative 9.8. If you're in physics, you know that negative 9.8 is gravity, meters per square. That's the acceleration of gravity, meters per second squared. So if you've taken physics or you're taking physics right now, some of this stuff will look familiar, and you might know the concepts. If not, it's okay. I'll go over a nice little review right here, right now. Okay, so I'm going to go over what the things we're going to be asked about, so you can see that this is one long problem, and you'll have one of these on your homework where you have to take the same equation, do a lot of stuff to it, answer a lot of different questions. So things like, what's the instantaneous speed, right, at 2? And from your work, you already know that that's asking to find what's f prime of 2. Right? So remember, if you're asked to find speed, right, speed is the derivative, right? Anytime you see speed or rate of change, right, that's a derivative. And of course, it's given us t, so we know to use 2. Right? So we have to convert all this stuff to mathese to know what we're actually doing mathematically. Right? So that's the goal here. What to find the maximum height? So this is asking to find height, right? So that's not the derivative, right? The derivative is only for speed, so it's asking for height. That means we're going to use our regular function here, because it says right here, it's launched in the air after t seconds, the height of the object. So that means that when I plug something into this function, my answer is a height. Right? And we have to know this before we do any math so we know which equation to use and when. Right? Otherwise, it's a big guess. If you're just doing numbers only, like one of those people that just skips directions on everything, and you just want to start doing stuff. Well, we have multiple functions to work with. We have to know which one to use. So I'm going to show you how that works and find out what the maximum height is. This says how long does it take. So this is asking for two things. How long does it take? That's time, right? And what's the maximum height? So it's asking two things here, right? Then it asks, how long is the object in the air, right? So as it's going up and coming down, how long is the object in the air? So here's a little thing about what we're going to use. You need to know this little physics principle. Okay. The time the object takes to get to its top here, which we're going to call it's called two things. From Algebra 1, that top point is called the vertex. You might recognize that. In sciences, it's also called the apex. So you might see that used interchangeably. Okay. And it takes some certain time from here to here, right, for it to reach some certain time for the height to reach the maximum point. So we call this the time it takes to reach the maximum. We say max, but it means max height. Whatever that time might be. It might be 10 seconds. It might be, if it's a rocket, going up from SpaceX, it might take, 20 minutes for it to get at the very top, right? So there's a principle that says however long it takes us to get up, it's the same to get down, right? So these two lengths of time are the same. They're both the T max. So if I know how long it takes to get to the top, if I double it, that's how long it takes to hit the ground. So that's just a very important concept when we need to know. Because that's one of the questions. How long does it take, or how long is this object up in the air? If I know how long it is from here to here, halfway, I can just double it, and that will give me the whole way. Okay. Let's see here. Oh, so if I want to find out, let's see here, how high this object gets, right? Here's where we start using our little calculus here. I can do this. Hold up. You'll notice that these have various slopes, right? This has a slope right here. This would be called the initial velocity. If I found out initial velocity, right? And that'd be after, like, if t equals like 0 seconds, that's called the initial velocity. The complement to that over here would be this would be called a terminal velocity. Just so we can know how to answer the questions, because it might be worded differently. Terminal. Right. So that'd be at the very last second, right before we might could be asked, what's the terminal velocity? Or what's the velocity right before it hits the ground, or when it hits the ground? The question could be asked several ways, right? So in this case, right, to find these, since it's velocity, we're going to use our derivative function, right? That would just be f prime of 0, right? Because that's when it's taken off, is at time equals 0. For terminal, it'd be whatever the total time is, right? So that's going to be f prime of 2 times whatever this max, right? This max is how long it takes to get to the center, so the length from here all the way here would be 2 times that. 2 times the... Right, so if it takes 4 seconds to get to here, right, it'd be 8 seconds. This whole thing was in the air, so I'd find f prime of 8, and that'd tell me exactly how fast it's going when it hits the ground. Now, if I want to find, let's say, this, how high this goes, right, or the time it takes to get here, let's do that one first. You'll notice these all have different slopes, right? These all have different slopes, and as I get higher and higher and higher, once I get to the vertex or the apex, you'll notice it's a slope of 0, right? And that's what we use to figure out when is this thing at its high point, is that the slope of it is 0. So that means we'll take this derivative and find out when does it equal 0. This is saying when does the slope equal 0, which is the same as when is it not moving, because technically it's not moving. It gets to a certain point at the very top where it's motionless and its slope is 0, and because it's going up and up and up, and then it's going down, down, down. You'll notice that all of these have positive slopes, so have positive answers on the way up. And if you're asked to find the speed as it's falling down, well, all these slopes, remember, speed and slope derivatives are all the same thing. So we expect all these to be negative slopes or negative answers, right? So your terminal velocity is always negative because it's going down and it's about ready to smash into the ground. And I already mentioned total time in air. I could put that one. I already said that a little bit, but yeah, the total time in air equals 2 times this T max. So all those will help us answer the questions that we need to find out. Okay. I think there's one more. Let me think about this. Oh, what is the actual height? How high does this get? Right? How high does that actually get? That's another question. If I want to know that, that's going to be, since I want to find height, I'm not using the derivative, right? I'm going to say, well, I'm going to plug in how long it takes to get there, and that'll tell me how high I'm at that point. So if I know at the t max, it puts me right in the center. If I put that into our original function, that'll give me the height at that point. So this would be the t max. So if I find f of t max, not f prime, but just f, right, that'll tell me how high this is at that particular point. So that gives us all the information I think we need to know. We can start cranking some of this out. And the first part, of course, since you could see, we need f prime of 0 or f prime of this or f prime of that, is that we're going to have to get the derivative, right? We're going to have to do that. So the first step on a lot of these problems and on all your homeworks is always going to be, let's find the derivative. So f prime of t, and start off with the definition of a limit. This will be your first question on your quiz, by the way, is what is the definition of a limit? You just have to know what it is, right? That's what we've been using. So you have to have f prime of t equals the limit as h goes to 0 f of t plus h minus f of t all over h. Okay. This is basically a slope formula. Normally we'd have t plus h minus t, right? And that looks more like the y2 minus y1 over the x2 minus x1. But this bottom always cancels to just h, because the first and last cancel out. So that's why we just put h. But it's still a slope formula. Okay? That's all we're doing is finding slope. So remember, rate of change, instantaneous speed, it's just finding slope. And then this part, this limit, is what makes these 2 points infinitely close to each other. Right? It's still 2 points, but they're so close to each other, it basically appears as 1 point. All right, and then we just go through doing the steps you already know how to do that you love so much. And yes, this takes a little while, but that's what we're charged to get good at this point. So plugging in t plus h into all these. If you want to just do this at your own pace, you can. If you want to follow along with me, you can as well. That's exactly what you've been practicing. Substitute in t plus h for each t value here. So one here that's squared, one that's right here times the 96. Okay. And I like putting square brackets around here to show that that's the first part. And then the second part is just f of t, the function in its original form, minus 16 t squared plus 96t. All over h. Okay? Get that going up here. There we go. Okay. I'm going to pause right here and let you guys do this part. Go ahead and simplify the entire top and reduce it. You know, you got to distribute everything and expand everything and combine like terms correctly. A lot of algebra, pre-algebra that you got to do right now. So I'll let you do that right now. Alright, so you should eventually get to this conclusion. Right there. Yes, you could. Yes, if you wanted to, you could take out a 16. You would just rewrite this as negative 16, and then 2t, well, it'd be minus, what, 4? 5. All right. Yeah. Okay. 6. Oh yeah, 6. So you could actually take out 32 then. Yeah, however you want to write it. Usually it's not factored. Your derivative function's usually not factored. But, yeah, however you want to do it. It's up to you. It gives you the same answer. So, now, we did step 1, right? We found f prime of t, but now we need to plug in 2, right? Because that was the original question. How fast is this thing going at 2 seconds? So, now with this equation, I can find out how fast it's going at any time. At 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, I can find out how fast the thing is going at any given point, right? But this particular question is asking just at 2 seconds. So f prime of 2 is negative 32 times 2 plus 96. Negative 32 times 2 is negative 64. And 96 minus 64 gives us 32. Okay. And our units are meters per second. So what this is saying, remember, that's great. We did a lot of math. We did mostly a big slope problem. What does this mean? Right? So at 2 seconds, wherever that might be, I'm just going to say it's right here. Let's say this is 2 seconds. Right there. It's saying the fact that the answer is 32 is, yes, that's how fast it's going, right? Which is equivalent to the slope of this line. So it's saying that the slope of that line, that tangent line right there, is 32. And no surprise, it's positive 32, came out to a positive number, which means this thing is on its way up, right? But that's graphically what that means. The slope of that line or the speed of that object is at 32.
On the question where t equals 2, I put 2 in before I took out h.
So if you put 2 right here from the very beginning, the thing is we need this equation for other parts of the problem. So if you did that and you put in t plus h, which would be a shorter problem on here, on the next one you need that equation to find the maximum height, so you'd have to go back and get it anyway. So whether you do it here on the next step, yeah, it's up to you. Good point. Good point. Yeah, because you'll notice on the homeworks, where do they go? Are they gone? Yeah, on the homework problems, you notice for all these, like at g of 2 and whatever, I put in 2 right away. I didn't do t plus h, get the derivative function, and then plug in 2. Just did it from the very beginning. So that tells me what the answer is, but if I needed to find it at 4 and 7 and 10, like I needed to use this function multiple times, I'd have to redo this thing over and over and over with a different number, which would take forever. So that would be the case on these as well. So let's see here. We want to find next, where are we at? Oh, how long does our next part is, how long does it take the object to reach maximum height? Right, how long? So the fact that it says how long, you know our answer should be t equals something, right? So it's not asking what the maximum height is, it's just saying how long does it take to get there. And going back up here, that's this. Alright, we're trying to find that t max, and that happens when f prime is 0, or f prime of t equals 0. Alright, to find t max, right, I need to solve this equation, and my answer to this equation is the time. Right? So And this is why we need this function, right? It's saying this function right here, when does that equal 0? So we want to find out when does f prime of t equal 0. And we know f prime of t is now negative 32t plus 96. So when is negative 32t plus 96, when does that equal 0? And this is a two-step equation, right? So subtract 96 both sides, divide both sides by negative 32. So subtract 96 on both sides, it now equals negative 96. And divide both sides by the negative 32, so t will equal 96 divided by 32, which is 3. 3 seconds. Right? And as promised, our answer is time, right? We got to make sure we're answering the question. I've seen this where people will automatically assume when it says how long, maximum height, I need to find maximum height. No, it's asking how long does it take to get there, not what is the maximum height. So it's a different question. The next question over here, sidebar. This comes up every now and then that, yeah, in Algebra 1 you learned how to find the vertex, and there is a formula to find the vertex in Algebra 1. You might recognize it, so a little sidestep back to COVID for some of you. Algebra 1, you learned that the vertex, if you use this formula, x equals negative b over 2a, that gives you the vertex, right? That was part of the quadratic formula. Opposite of b plus or minus the square root of 4 minus b squared minus 4ac all over 2a, right? This is part of that equation. So in this case, if I went up here, a would be negative 16, b would be 96. If I plug those into this Algebra 1 format, I'd have negative 96 over negative 32, and wouldn't you know, it comes out to 3. So you can use that as a little check. And regardless of how you did this, right, to find the height, I want to find how high this thing is. You just do f of that value we just got. So we just found out our T max is 3. It takes 3 seconds to get to the center. So if I plug 3 into our original function, right, that'll tell me how high this gets, right, what the height is at 3 seconds. So f of 3 we need to find out. F of 3 seconds. So we have this function right here, just plugging in 3 for t. Negative 16 times 3 squared plus 96 times 3. You note it's nice to have a little calculator handy for some of these. So negative 16 times 9, which is 4 times 4 and 3 times 3, which is the same as 12 times 12, which would be negative 144. And then 96 times 3 would be, 300 minus 12, which would be 288. And this happens to be half the size, so negative 144 plus that gives you a positive 144. Okay. And what are the units here? Meters, right? Meters. We just use m for meters. And that's what we just found up here. The maximum height is 144 meters. So the vertex is actually at 3, 144 if we're plotting it. That's what the vertex is. Pretty cool. But wait, there's more. How long is the object in the air? What's the answer? 6, right. So we know it's 3 to get to the halfway point. And how long is it total? Double it, right? Total time in air is 2 times the max. 1 for the first half, 1 for the second half. That's how we get 2. So that's a quick one. Let's go bing. So I'm going to write this in a certain way. Total time in the air is going to equal 2 times the T max. Just so you can see where I get it from. So on the next problem, you know what values I'm using. So total time in the air is going to be 2 times 3 seconds. And that's how we get 6 seconds. Not too bad. Okay. And lastly, what is the speed of the object the instant it hits the ground? Right? So that's going back down. Is this answer going to be positive or negative? Go back to the graph. Remember, speed and slope are the same thing. So what's the slope when we hit the ground? Negative, right? So this whole downward, these are all negative because they're all going down, right? So we expect a negative answer. And it says right here that terminal velocity is f prime of what we just found, right? Which is 6. So we need to do f prime of 6, right? That's the total time from here all the way to here. We found out on the last problem it's 6 seconds. So if I wanted to find the height, of course, if I plug in 6 into here, I'd get 0 because it's on the ground. But the derivative will tell me how fast it's going, right? Tell me how fast it's going. So f prime of 6, go green. So we used this twice. We first did it with the first question. It said how fast is it going at 2 seconds, and now we're doing it again at 6 seconds. Of course, we didn't know at the time that 6 is when it's hitting the ground. We had to go through this work right here to find out, oh, it's 3 seconds to halfway, and then we had to double it to get 6 seconds. Then we can plug it into the derivative formula to give us the speed at that particular time. So we got negative 32 times 6 plus 96. What, 180 plus 12, 196. No, 192. Yes, plus 96. And sure enough, a big negative plus a smaller positive, we'll get a negative answer. That's good. If I didn't get a negative here, I'd be in trouble. So that comes out to negative 96. And since it's a speed, it's a rate, right? As soon as you see this, you know our units, what they should be. Hits the ground, you know it should be a negative. Okay, so that's an example of one problem, right? You can expect a whole problem like this on the quiz and on a test. Right? It's a pretty standard type of problem. Sometimes it's a projectile motion, something going into the air. There's another problem, a classic problem that deals with particles. So you deal with a physical that's really big and grand, like some big object going in the air. But we also deal with this very, very small atoms and particles that are moving in certain places, right? And all the rules are the same. So it's interesting that at this huge physical level, or a very small level with particles, right, the calculus is actually exactly the same. Pretty cool. So what you're going to do, you got a little bit of time today, is you're going to start working on this right here. Okay, and this is what's going to be due. This is going to be Monday's homework due tomorrow. And this worksheet is going to be what you get tomorrow due on Wednesday. So this is Monday, Tuesday. I should put that there. Assigned and due, and then this worksheet is assigned and due Wednesday. And we might have some time on Wednesday to actually work on this. I haven't kind of figured out that yet. But if you want to start that, if you wanted to do the bookwork today, that's fine. And tomorrow you can come get this worksheet. But if you're ambitious, you want to do both, you can come grab this. It's under the Tuesday up here. and I'll post this key as well as some example for the bookwork for tonight. I'll post some examples. So the second part of the homework is like this. The first part of the homework is actually practicing derivatives, but using formulas for like circumference and area and volume and things that you know from geometry. So you can do derivatives of all the formulas from geometry and area, volume, surface area, and everything. So we'll get a little practice at that as well. So if you need any extra help, check the examples that I'm about to post.